Welcome back to another episode on a new series of Postgres. In a previous episode, we've learned how to run Postgres in a Docker container, as well as learning about how to configure Postgres using configuration files. In this video, we're taking a leap of faith and we're looking at how to turn our Postgres into a primary server, and then setting up a standby failover server, so when our primary server fails, we can fail over to the standby server. So we'll be taking a look at primary and replica streaming replication. It's a very exciting episode, so without further ado, let's go. Firstly, we'll launch our Postgres instance, but this time we'll call it Postgres 1. We'll persist our data in a volume. We'll take a look at archiving and write-ahead logging to increase our data integrity. Then launch a container that will take a backup of our primary instance, and it'll automatically create new data directory that is set up to stream from the main directory using a utility called pg-based backup. This will give us a volume from which we can launch a second Postgres instance, which will launch in standby mode. So if we take a look at my GitHub repo, all my Postgres related guides are under Storage, Databases, Postgres. And in here are the guides for part 1 all the way to part 5. So if we go to our introduction, there's a README. And this is part 1 where we've taken a look at the introduction to Postgres, all the steps of learning how to run Postgres in a Docker container and persist data, as well as the networking involved. For part 2, we have the configuration folder and a README. And in part 2, we've taken a look at how to configure Postgres and taken a look at all the configuration options and the different configuration files involved. In this video, we'll be taking a look at replication, which is under the part 3 folder, and there's a README. And this introduction talks about how to replicate Postgres. We'll get a primary Postgres instance up and running and take a look at what it takes to set up a streaming replica. So be sure to check out the link down below to the source code so you can follow along. So the first thing that we need to do is get our primary Postgres up and running. So we'll take a look at what we learned in part 1 and 2 and run a Postgres instance in Docker. But there's going to be a few things to note here that we'll do slightly different. In the first video, we called our Postgres instance Postgres when we gave it a name. This time we're going to start each of our instances with different names so they can be identified. So instead of just creating Postgres, we'll call it Postgres-1. That'll be our primary instance, and then we'll have Postgres 2 and 3 and 4 and so on. Then we'll also set up unique data volumes between each instance, because each Postgres instance needs its own data directory and persist its own data. We'll create unique configuration files for each instance so they can be configured separately. And this is important for replication. And we need to create and run these Docker containers on the same network so they can talk to each other. So it's important to understand that each Postgres instance needs to run on the same network. So when running in something like Kubernetes, you need to take advantage of Kubernetes services and Kubernetes DNS. When running in Docker, we can use the Docker container names as a domain name so the instances can talk to each other. So first things first, we create a new network called Postgres by saying Docker network create Postgres. So now that we have our network ready, we need to get the configuration files ready. Now in part 2 of our Postgres series, we've taken a look at configuration. So under Storage, Databases, Postgres, under part 2, we've created this folder called config, and we learned about the HBA config, the ident config, and the Postgres config. So what I'm going to do is take what we've learned there. I'm going to copy these 3 files, and under my replication folder, I'm going to create 2 new folders, one called Postgres 1 and one called Postgres 2. You can create as many instances as you like. And what I'm going to do is I'm going to copy these 3 configuration files into each of these folders. So I'm going to select Postgres 1, paste my configs in there, and then under Postgres 2, I'm also going to paste configs in there. So I set up my configuration files ready for Postgres 1 and 2. Now this will just start 2 separate Postgres instances individually. So to start up a Postgres 1, what we do is what we learned in part 1 and 2, is we say docker run interactively, I'm going to run Postgres 1. I'm going to run it on the Postgres network. That is important so they can all talk to each other. We're going to take what we learned in part 1 and 2 about the configuration. So I'm going to set a Postgres username and password and just create a default database called PostgresDB. I am also going to take what we learned about persistence. So what we want to do is set our PG data folder to /data and then mount in that Postgres 1 folder, PG data, into /data, and then also mount Postgres 1 config folder into the config folder inside the container. And what I'm going to do is create a separate folder called archive, which we'll take a look at when we get to replication. So 3 mounts. There's going to be the data to persist, the configuration, as well as the archive. And then I'm just going to expose it on port 5000 as we did before. And I'm going to start up Postgres 15 and I'm going to tell it which config file to load inside the container. So you can see we just got to fix up our configs on the left here. I'm going to create a new folder called config. I'm going to move these 3 configuration files into there. Go ahead and move them. I'm going to do the same for Postgres 2. Create a new folder called config and move all of these configuration files into there. This means what we will see when we run this container is we're going to see 3 volumes per instance. We're going to see the config volume, the data volume, as well as the archive volume. Go ahead and run this container, and now you can see Postgres is starting up and initializing. And on the left side, you can immediately see the 3 volumes, the archive, the data, and the config. Now with our container up and running, we need to set it up for replication. And in part 2, we've learnt about the authentication configuration file. So what we need to do now is set up a replication user that has capabilities to do replication by editing the authentication config and allow it access to our primary instance. So while this instance is up and running, I'm just going to open up a new terminal, and then we need to create the replication user. And to do this, we need to go inside of that container. So we go docker exec -it, go into Postgres 1, and now we're inside. And then what we need to do is set up a user. So we say create user -u Postgres admin -p -c5. This is the connection limit for that user that we want to allow. So we allow it up to 5 connections. And then we say -- replication, which tells Postgres that this user needs replication capability. And we're just going to call it replication user. This is going to be our username. So let's go ahead and create that user. And for the password, I'm just going to call it replication password. I'm going to enter it again. And now we've created a user. So I can go ahead and exit out of this container. So what we have to do now is allow this user to access our database. And we do this by editing the access configuration file. So under our Postgres folder, under the replication folder, we're going to tweak our Postgres 1 instance. We're going to tweak the config, and we're specifically going to tweak the access file, the hba.conf. So we're going to keep everything as is, but we're going to create a new entry for that replication user. So we're going to say type is host, the database type is replication, the user is the new user we created called replication, and the address is just to allow it to connect from anywhere using an MD5 password format. Now there is quite a lot to learn about Postgres high availability, and the first most important thing to learn is about write-ahead logging. This feature is designed to protect data integrity. When Postgres does a transaction, it will write it to a transaction log and flush it to disk. And it will not consider this transaction to be complete until it's been written to disk. This feature is called write-ahead logging. And we'll want to go ahead and enable this because this is the core mechanism used behind replication. So to go ahead and enable write-ahead log and replication, we need to take a look at the documentation. So I've placed the link to the official documentation in my README file. This talks about write-ahead logging with everything we've discussed before. Write-ahead logging is a standard method for ensuring data integrity. So basically, Postgres has a mechanism of writing transaction logs to file and does not accept the transaction until it's been fully written to the transaction log and flushed to disk. So the reasoning for this is if there is a crash in the system, the database can be recovered from the transaction log. This is why it's called the write-ahead log, because it's writing ahead. Now I've added documentation for these two settings. The first one is the wall level. So this determines how much information is written to the log. The default value is replica, which writes enough data to support write-ahead logging for archiving and replication. So this is very easy to do. We just go ahead and set the wall level to replica. The next setting that's important is the max wall senders. This is an integer number and specifies the maximum numbers of concurrent connections from standby servers or streaming-based backup clients. So we'll go ahead and set that to 3. The next feature we'll want to enable is archiving. Archiving is the process of archiving the transaction logs so that we can recover Postgres from any point of time in the case of failure. So we want to go ahead and enable this and also archive it to a volume so that it's persisted. So when our container dies and restarts, we don't lose our archive. So to enable archive, it's very simple. It's just 2 settings: archive mode to turn on and the archive command. This is a command that Postgres will run every time a wall segment has been written to the log. So according to the documentation, we've got archive mode. This is turning it on or off. And then the archive command is a local shell command to execute to archive a completed wall segment. And here they talk about the parameters P and F, which is replaced by the file name and the path name. So we're going to set a simple command to test the path and then to CP, just copy the file to the archive directory that we mount in. Now, if you've taken a look at our docker run command to start our container, notice that we have created a volume for this archive. This volume is on the left hand side here. You can see the archive has been created and it's mounted to MNT server archive. This path has to match the CP command here because this is where we're going to be copying the archive log to. So once this copy starts happening, we'll see the files in our volume appearing. So what we want to do is take these 4 settings, go to our Postgres SQL.conf file, and right at the bottom we want to go ahead and paste that. So this is our settings we need to enable replication and archiving. So to test this, what I can do is just press Ctrl+C to stop my Postgres container, clear out the terminal and do the docker run again. And if we stop our database by pressing Ctrl+C, you notice if we take a look on the left, the archive has started writing here. Now there's not much activity on this database, so you won't see the archive being written a lot. So I had to actually stop my Postgres container to force it to start writing to the write-ahead log, so it archives the data so we can see it's working. Now the next step is to go ahead and set up and run our standby instance that will stream from the primary. Now one thing you'll notice is when learning Postgres, that Postgres does not have a lot of features for high availability built in, but it does provide a lot of native tooling to achieve high availability. One such tool is PG-based backup. This is a tool that is used to create standby instances and backup Postgres databases. It'll connect to your primary instance as a replication user and then take a backup and restore it to a data folder. That data folder will look almost like the same data folder of our Postgres primary instance, but this data folder will be ready and set up to receive replica requests from the primary. So what we'll do is use this utility to take a backup of our primary data folder and create a new data directory. Then we'll take this data directory and make a new Docker volume for our secondary standby instance. And once this new secondary instance starts up, it'll automatically start to read the transaction log of the primary server and start the replication process. And it'll technically run as a read-only instance. So to start this process and create our standby instance, the first thing we'll need to do is take a database backup, and we'll use the PG-based backup utility. Now this utility is built into the Postgres Docker image, so we're going to run another Docker container without running a Postgres database. We're just going to override the entry point because we want access to the PG-based backup utility. So what I'm going to do is in a new terminal, I'm going to change directory to this replication folder, and that is because inside this replication folder is all our instance configurations. And what we're going to do is we're basically going to set up the data directory for our second Postgres instance. So to do that, we use PG-based backup, and to get access to it, we're going to say docker run -it. We're going to remove the container when we're done. We're going to run on the Postgres network so we can access our primary instance. We're going to mount a volume, and we're going to mount the Postgres 2 folder, and we're going to mount the PG data folder because that's going to be the data directory of our second Postgres instance. And this is where the PG-based backup utility will dump the data directory. So we mount that in because we want to persist it, and then we override the entry point to just bash because we're going to run some commands. and we run Postgres 15. So go ahead and copy this to the terminal, and now we're inside a Postgres container without a Postgres server. We can technically now take a backup by logging into Postgres 1 from this container and using the PG-based backup utility to take a backup. And we do this by just simply using the replication user that we created earlier. This will write all the data to /data, which is our volume mount. So to do this, all I do is say PG-based backup, the host I want to connect to, which is my primary instance, the port to connect to, the user to use, where to dump the output, and a couple of extra parameters. I go ahead and run that. It'll ask me for my password. My password is replication password, and we will see it do its magic. You can see that takes a few seconds, and when that is done, you will notice, if you take a look at our volume, you'll first notice that some archive has been written. There's a backup that's been taken as part of the Postgres 1 archive. And more importantly, under Postgres 2, you'll notice that the PG data folder is now occupied. It's been populated with pretty much the data volume, the data folder of the Postgres 1 instance, but it has replication and streaming capability. Now the data volume for our secondary standby server is ready to go. Also remember that we have separate configurations for our standby server that we copied from part 2 of our series. So now we can go ahead and start the secondary instance. So now to start the standby instance, what I can do is I can just exit out of this container we used before. Just make sure we are in the replication folder, so we are in the right working directory. This is because we want to make sure we access all our configuration files that we can use, as well as our volume. And I can then start my secondary instance by saying docker run -it. I want to run Postgres 2 as the name, run it on the Postgres network, pass in the similar environment variables as before. We want to mount a similar data directory. We want to set a similar data directory. We want to mount in all our configs, and this time we are mounting in Postgres 2 folder for the data volume, as well as Postgres 2's configuration files. And what we're going to do is we're also going to enable archiving on this server as well. And then the port we want to expose, this time I'm just going to increment the port number to port 5001 because 5000 is already in use. And I'm going to run Postgres 15 and tell Postgres where to get its config file from. And then I copy paste this to the terminal and I press enter, and that will start up my standby instance. And you can judge by the logs, you can see here entering standby mode, and it also says it's starting streaming wall from primary. So you can see this one is ready to start writing its entries from the transaction log of the primary server. Now to test the replication, what we can do is just log into our Postgres 1 database, go ahead and run psql to log in, go ahead and paste that. And now I'm in the database. Let's go ahead and create a new table called customers, and let's show the table. And we can see our customer table has been created. Now what I can do is I can exit out of this Postgres container as well, clear the terminal. I can log into our Postgres 2 instance, use psql to log into that one, and now I'm in. Now the moment of truth, if I say /dt to show the tables, we can see that our table has been replicated across. So we know our replication is working. Now to simulate a failure scenario, what we'll do is go ahead and shut down server 1. Now Postgres doesn't have native failover built in, but there are tools to support this. Postgres has a load balancer tool that you can use that can help with automatic failover. Now to showcase failover, what we'll do is we'll manually failover using the pgctl tool. Now this tool will run against the standby server and turn it from a read-only standby server into a read-write instance so that it can be used as a primary. So to showcase this failover, what I'll do is I'll say docker rm-f Postgres 1. So pretend we lost our Postgres 1 server and it's no longer running. What we then do is we log into Postgres 2 and we promote it to a primary. Now what you'll notice is at the moment it is a secondary server, which means it's a read-only copy. If you try to create a table, you can see that it cannot execute create table in read-only transaction. So what we need to do is say run user, and we want to run as the user Postgres because it cannot be run as root. Then we want to run pgctl promote command. This command will promote it to a primary instance. Go ahead and run that, and it is waiting for the server to promote. and the server is now promoted. Now we can go ahead and confirm it's a primary by creating a table, and we can see the table already exists. So now Postgres 2 is a primary instance, and we can use the same method to now create a Postgres 3 or a 4. So now you understand the basics of how to run and configure Postgres, as well as how to take backups of Postgres and configure standby replication. So to summarize it, this is what we've done. We've spun up Postgres 1. Postgres 1 writes its data to PG data as a volume to persist its data. So when Postgres dies and comes back, it'll get its data from the PG data folder. It also writes its archive to the archive folder. The PG-based backup utility is then used to contact Postgres 1 and generate a new PG data folder, which is used as the volume for Postgres 2. And then Postgres 2 can also be configured to write its data to archive as well. And we can set up replication to even start writing to other instances. And it's very important to understand these fundamentals, because when running Postgres in something like Kubernetes, a lot of the Kubernetes controllers for Postgres use these features in order to work. They simply automate these fundamental principles. And that is how you create a basic primary Postgres server and a streaming read replica instance. In the next chapter, we'll take what we've learned in part 1, 2, and 3, and we'll learn how to get a basic Postgres instance running in Kubernetes using all the concepts we've learned before. And you'll notice similarly how we had challenges running this in Docker, we'll have certain challenges running stateful workloads in Kubernetes and how to overcome some of them. There is still so much more to learn, so if you liked the video, be sure to like and subscribe, hit the bell, and if you want to support the channel even further, be sure to check the Patreon link down below or click the join button to become a YouTube member. And as always, thanks for watching, and until next time, peace.